Let's check the data path for branch instruction. As you know, in the branch in instruction, we check the content of two registers if they are equal or not equal according to the branch equal instruction or branch not equal instruction. Then the control flows to the special instruction that is mentioned by label. So as you can see, the content of two registers will be read from the register file and they will be given to the ILU or if you perform the subtraction operation over them. And according to the zero flag, we can find out that the content of that two registers are equal or not. And if it is satisfied the condition, then the program content should be loaded by the target address. The target address is computed from the 16-bit relative address that is inside the instruction part. And this 16-bit will be performed or extended by sign extension module. Now we have a 32 bits. This 32 bits will be shifted 2 times to the left. If you remember, when we want to find the relative address, we subtract the target address and the current value of the program content, and then we will divide it by the 4 number of words that are between the source and target. So in order to again compute the number of bytes, we need to multiply this number of words by 4. This is performed by shift left 2 times. And actually there isn't any hardware for this operation. You can easily connect the wires from the input to the output. Each one shift the tool bits to the left anyway. After shifting the relative utterance 2 times to the left, it will be added with the current value of the program counter. Program counter is now points to the next instruction. So program controller +4 and this relative address will be added together to find out the branch target address. Let's check them in the simple animation data flow. Well, as you can see, R is an RTR given to the register file and the related pathways is also given to the extender module. And now we have 32 bits here and it is shifted 2 times to the left, and here the content of the register or RT and the content of the register indexed by R are read from the register file, and now they are given to the value. You perform the subtraction and according to the value of the zero flag, the branch should be performed. Or we should ignore it and go to the next instruction. So if this is a zero flag is true, then we will move to the next and move to the target address if the instruction is branch equal. So this address and the current value of the program counter will be together to determine the orders. And this orders should be loaded back into the program counter. Okay. Let's combining the data paths for our typing instructions and load the store instructions by using 2 multiple cells, one here in the input of the value and one here to select between the type of data that we are going to store back inside the register file. Is it coming from or from the result of our value, or it should be come from the data memory? So as you can see, we inserted 2 multiple excerpts here. Let's check the executing of each instructions in this new data part. First, for the hour typing instructions. Let's see which part of the data path will be used. So the RDR is an RTR coming from the instructions and given to the register file, then to data, will be read from the register file. One of them is directly given to the ILO. Another one will be given to this multiple Excel and OIL. USource will select which one of these two inputs should be given to the OIL U. In this case we are going to use the upper input, so the OIL source should be 0. Then these two data will be computed, and according to the operation of the R-type instruction, 1 of the mathematical or logical operation will be performed over them, and the result will be given to the second multiple Excel. So second multiple Excel should select this input. Therefore the signal memory to reg should be 1. If it is 0, then the first input will be select. But in this example we are going to select this one. Therefore, this input should be 1. And the result come back and come to the register 4. Let's take it again. Who they will be read. And even to the view, and the result come back, and it's all inside the register file. So the highlighted parts, that indicates the part of the data part that is used by the R-type in instruction. So the control unit is responsible to assign the corresponding value to the source and memory to register, and the other ones in order to execute this instruction inside the process. Let's check the load in a fraction. You can see it's part of the Datapath does not use in here. And the 16-bit offset is given to the extend module and convert to the 32-bit. And this 32-bit will be given to the OIL. So again, we have a multiple Excel here, and this time the second input of the multiple Excel should be select. So all use source should be 1 for the load. Yes. Then this result will be given to the memory module, and the content of that memory address will be read. And it is here, and it is given to the second multiplex, so memory to register should be 10 here, because we are going to select this input and put it into the output of the multiplex. I need to come back and write back inside the register file. Let me show you again. To oily sauce should be 1 and memory to register should be 0 for the load word instruction. For the store warden instruction, these are the part of the data that will be used. Can we find the address of the memorial location that we are going to store this register inside it? By using the value, and this multiplex cell should be, again, 1, because we are going to select this part of the path or data path actually and giving to the idea. And the second register is giving to the right parts of the data memory. And we don't want to write back the result inside the register file. Therefore the register write should be 0 and memory register can be 0 or 1. So we can consider it as don't care. Memory write should be 1 memory. It should be 0. Operation can be should be add, because we only want to add the base order with the offset to find the address of the memory location. So the operation here should be always add for the stored. And our resource should be 1, as I mentioned before.